Alright guys, so in this lesson we're going to be talking about transformations of functions. We talked about parent functions last time. We took a look at some of those standard graphs, those graphs that we're often presented with. Today we're going to learn how to take those graphs and make things change a little bit. So you're used to just what the graph looks like in its standard position, and some of those basic qualities of those graphs. So, and as we know, most equations are not just as simple as, y equals x squared and so on. Sometimes we're going to see that, things kind of happen that move this graph around. And we're going to take a look today at what those changes do to the graph. The first and the most basic kind of change we run into is a vertical and a horizontal shift. A vertical and a horizontal shift, just as it says, takes this graph and moves it up, down, left, right, depending on the numbers that you see along with the graph. So let's say that C is some positive real number. Vertical and horizontal shifts in the graph of your standard parent function, whatever it is, y equals f of x, it's represented by the following. This thing shifts up. The whole thing will move, has a vertical shift so many units up if you see the function itself plus that value of c. This thing is going to have a vertical shift that is down if you see the function itself, and then it says minus c. Now, as far as moving up and down, it's being added or subtracted to the function. However, when it moves horizontally, when this thing moves, let's make this purple. When this thing moves horizontally, that is left and right, it moves to the right if you see a minus c. It moves to the left if you see a plus c. Now you're probably thinking, well, to the right are the positive x values, to the left are the negative x values. So how does that even work? A couple of things to remember. First of all, if you see on the inside, if the letter C is on the inside, if you see it inside with the function directly affecting the x, this is going to be the opposite direction. Those changes that affect the x are in the opposite direction of what you see. Now, why is that, you might ask? Well, it's because this thing has been moved, left and right. Now, when I'm solving an equation, for example, if I see something like parentheses and x minus 4, well, most equations, and especially parent functions of equations, are used to going through 0, 0. So most of them go through the 0 point. So why is it that it says, x minus 4, this thing is going to go to the right? Why is it going to go to the right? Well, let's take a look. Let's say this x minus 4 was equal to 0. That means this thing's gotten offset by 4 units. When I solve for x, oh, notice I get x equals 4. So it is, in fact, to the right 4 spots, because what used to be x equals 0 is now x equals 4. So hopefully that sheds a little bit of light to as y. When you see it on the inside, it's in the opposite direction. But that's exactly what you need to pay attention to. Here, it's going to move up, down if it's on the outside. That is, it's affecting the function itself, outside the function values. Here, the number's on the inside with the x, inside the parentheses before a square or a square root or whatever the function is takes over. Before that comes into effect, it's affecting the x value. It's inside, it's going to be in the opposite direction. So it's all about the location of the vertical and horizontal change that takes place. Take a look at a vertical versus a horizontal shift. The result is 2 in the positive direction for each case. But look at how it shows up in the equation. This is our x squared, f of x equals x squared. That is our parent function. That is our quadratic. And we say x squared plus 2 on the outside, and we notice that this thing moved up 1. So there's the 0, 0, the normal point, moved up 1, 2 spots instead. So that this one here went up 2. Now this one went from here, but it went to the right 2 spots. This went to the right 2, but inside the parentheses we see a minus 2, and notice that that's before the square comes in. So that's happening directly to the x. It's the opposite. So if you see a minus 2, it's going to go to the right. If you see a plus 2, it's going to go to the left. However, if that plus 2, like we see here, is on the outside of the function itself, it's going to move up or down instead. So it's a little tricky, but just watch for the location of that transformation, that value they're either adding or subtracting. So what I want you guys to do is I want you to try to graph these without a calculator. That is, remember what we talked about with parent functions, and then apply only transformations to these and see if we can graph these. I want to do a couple of these with you, but if you guys want to pause and try this first on your own, please go ahead and do so. If not, let's go ahead and get started. Our parent function, I'm going to change some colors to make them stand out a little bit. We're going to try to put these on the same graph as much as we can before they start getting too crowded. So let's start here with the parent function. And I'm just going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you can make the graph bigger if you want. I think this will do for us. We don't need too many points and too many tick marks, so we'll just go with that. My parent function of x squared, if you don't remember what it looks like, just pick your table of values. Negative 2 squared becomes 4. 1 squared becomes 1. 0 squared is 0. Excuse me, negative 1 squared is 1. So is 1 squared. 2 squared is also 4. If you remember, this is an even function. It is always it's increasing from 0 to infinity. It's decreasing from negative infinity to 0. It has a minimum value of 0, all those things we mentioned before, but we're just asked to graph it. So there you go. Parent function, y equals x squared. But then, okay, let's apply some transformations to this. Let's start with blue. So the first one says that you're going to take this equation, the x squared, and you're going to add 4 to the equation. So which way does this make this equation move? So plus 4 is going to go up 4. So if you know what the original looks like, all you have to do is take every point you see there and move every point 4 units up. So 1, 2, 3, 4 is the middle. 1, 2, 3, 4. 1, 2, 3, 4. I'm not going to bother with the other ones because they're already off my chart. And then we connect those points. And eventually it's going to look like these are getting closer and closer. It's because they are. Because the x won't change as much and the y changes a lot more because of the square. But either way, for the most part, and through its entire graph, it's going to stay inside of the other one. They'll get really close though. So this thing just took the original and moved it up 4. All right, on the next one, notice that here, we haven't talked about this just yet. So let's actually save that one for just a minute here. Let's go ahead and jump to number 4 next. Just because we haven't talked about what happens with a negative in front. We're going to revisit that. So we graph this one. Now notice there's a lot going on there. We have a number on the inside that's being added. We have a number on the outside that's being subtracted. So what does that do to our graph? The inside plus 1 tells you to go to the left 1. The minus on the outside tells you to go down 3. So remember, the inside is always opposite. So plus 1 on the inside, it's really to the left 1 spot. So here we go. Let's go ahead and move this to the left 1 and down 3. That's only 2. left 1, down 3. Then this point, left 1, down 1, 2, 3. Left 1, down 1, 2, 3. And you notice it's still maintaining that parabola shape. And just to get a more accurate graph, let's go ahead and do this one because it's going to be in our graph. Left 1, down 1, 2, 3. Left 1, 1, 2, 3. And we have a point that coincides there. And that's okay. It's starting to get crowded. So there you go. That's probably not the best shape, but gives us an idea. Again, we're asked to sketch these without a calculator. You get close enough, I'm happy with that. Alright, so that takes care of those ones that just either move up, down, left, or right. I do want to take a look at what happens with number 3 and looks like number 5. But we're going to create a different graph for those. So we're going to come back here. Let's make this one green just for a different color. Well, let's start off with the parent function so we have something to work off of. So 1, 2, 3, 4, 5. And 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And there's our parent function. There's our original parabola. Again, just a sketch. But this time, I want to see what happens when I have the negative in front of the x squared and the plus 4. We haven't mentioned that just yet, but we will. And when we talk about a negative in front, if you remember that from previous lessons, a negative in front of this whole thing is going to take the equation and flip it upside down. So this one is going to go up 4, but it's also going to reflect. You do have an option of which one you do first. I always like to reflect first. It's just easier that way. You take your graph and just go ahead and flip it first, because otherwise you have to be mindful of where this thing is moved first before you start flipping the points, because you're not flipping over the y-axis, you're just making it upside down. So best thing to do is to actually go ahead and reflect. That means that for here, 0 becomes negative. So negative 0 is still 0, then you move it up 4 spots. Then 1 is now negative. So then when you plug in a 1, it's negative, it's positive 1, but you're going to make it negative. So that positive 1 comes down here and then goes up 1, 2, 3, 4 spots. So same thing here, that 1 goes to a negative 1 and goes up 1, 2, 3, 4 spots. So the positive 1 goes to negative 1 and goes 1, 2, 3, 4 units up. Positive 4 goes to negative 4 and goes up 1, 2, 3, 4 spots. And likewise, we have the same thing on the other side. So this graph looks a lot like the original, even looks like the blue one that we had a second ago, but the blue one upside down from the spot that it moved up to. So that's what I was saying earlier. If you want to go ahead and move it up 4 spots, you can, but then you have to flip it and reflect it from that spot. So then notice how the blue and the green, they have the same starting position, but one's going up, one's going down. All right, so let's take a look at what happens with number 5. Let's make this one purple. And we're going to save the cubic functions just so we're graphing those here in just a little bit. We're actually going to separate those from the others because there's no point on putting a cubic function along with a quadratic. So for this one, number 5, this one has a +2 on the inside, a +5 on the outside, and a negative in front. So this is going to go, the +2 tells you to go to the left 2. It's going to go +5, so up 5, and it's also going to reflect. So +2, or left 2, up 5, and reflects. Now reflecting over the x-axis if you want to do that first, or it can reflect after you've moved it. It's up to you, but Just keep in mind every point from the original has to do all of this. So the first thing you might want to do is actually reflect it. And so 0 becomes negative, then it goes to the left 2 spots. And then it's also going to go up 1, 2, 3, 4, 5 spots. Kind of missed on that one. That's, again, an estimated graph. We're okay with that. Then for my negative 1, it's going to reflect, so it's going to be positive 1. It's going to go to the left, or excuse me, positive 1 becomes negative 1. Goes to the left 2 spots, and then up 1, 2, 3, 4, 5. Again, my graph is not very well drawn, so these are getting to be tricky. So positive 1 goes to negative 1, goes to the left 2, and then goes up 1, 2, 3, 4, 5. Hey, it's starting to look like a parabola. And then same thing if you want to take this one, negative 4 or positive 4 goes to negative 4, goes to the left 1, 2, goes up 1, 2, 3, 4, and then 5. And likewise this one, negative 4, left 2, up 1, 2, 3, 4, 5. And it should match. Again, it's a little lopsided because I'm not very good at drawing. That's why I do math. And then you just connect them. So notice in each one of those transformations that took place, it was just our original x squared, and now we've moved this thing around a little bit. All right? So as I promised you, numbers 6 and 7, we're not forgetting about them. We're just doing these separately. So using the graph of x cubed, sketch each one of these. So if you want to go ahead and try this out, again, don't just type these in on the calculator. We can do these by hand. You just have to remind yourselves and remember, what is the original graph going to look like? What transformations happen to my graph? And then I just move those points around. So let's talk transformation-wise. What is happening to x cubed if I say minus 1 on the outside? The graph is going to go down 1. What's happening to the graph here if I take plus 2 on the inside before you cube it, then plus 1 on the outside? This thing is going to go to the left 2, again opposite on the inside, and the inside moves left and right, and it's also going to go up 1 spot. So let's take a look at the first one. As we said on the first one, this thing is going to go down 1 unit relative to the graph of x cubed. So the graph of g of x being equal to x cubed minus 1, downward shift of 1 unit, and it is shown in this graph right here. All right, so again, if you weren't sure what that should have been like, we go and graph the original. So we're going to say, okay, what's x cubed look like? That is negative 1, 0, 0, and 1, 1 as my 3 main points. And so I can connect those with the S curve, and it flattens out in the middle, then it picks up real fast again. And then for the transformation, you literally take every one of those points and move it down 1 spot. There it is. Move that one down 1 spot. This one is kind of running out a little bit, but we can still see it. And there you go. There's those same 3 points, the shift of 1 unit downward. As you notice, there's a wider gap at 0, of course, because that's a full 1 unit shift. And then at 1, even though it's a full 1 unit shift, you look on the sides of it, it's getting kind of squeezed together because the x's don't have to change very much for the y's to change when you cube something. The y's change a lot more rapidly. So it looks like it's getting closer, but they will not run into each other. So again, g of x being equal to x squared minus 3 equal x cubed minus 1. I'm just stumbling my words today. So x cubed minus 1 results in a downward motion of 1. Likewise, we talked about x plus 2 cubed, quantity cubed, plus 1. This is going to involve a left shift. We start on the inside, left shift of 2 units. Remember, it's opposite for the inside. And this is going to go up 1 unit. Oh, don't want to move that. I do want to get rid of these guys though. So what does that look like? Well, our original, we know what that's supposed to be. And let's plot those same points again. Negative 1, 1, 0, 0, positive 1, 1. And let's see what happened here. So it's going to go, we said left 2, up 1, right? So left 2, up 1. There's that center point. There's that 0, 0 that's gone over 2 to the left and 1 unit up. Then do the same thing for this guy. 2 left, 1 up. This guy, 2 to the left and 1 up. And there you go. As you notice, each one of those points moved exactly what it told you that it was going to do. Left 2, up 1.